Hello everyone. Today let's just study about loss function. So loss function is a very important concept in machine learning algorithms. So in machine learning algorithms, we need to find out what is the accuracy or what is the performance for a particular machine learning algorithm, or compare with a set of machine algorithms with other set of algorithms, or by changing the tweaking the parameters. So in order to check what is the loss, for what we do is we collect the predicted values of the algorithms. So you're going to give input values and you run it to the machine learning algorithms and get your predicted values. With these predicted values, what we will do is we'll compare with this one with the original values. So this happens during this particular loss calculation we normally during the training process, or calculating the gradient descent, or comparing with other set of algorithms. So what we do is whatever predicted value is there, we will compare with the actual output value, and we'll take the differences. So there is something called a regression loss. So in order to calculate the regression loss, what we do is we take the differences, and out of differences we'll square the differences and take the mean of those differences. And after taking the mean of differences, we will do square root of those differences. After doing that, we will get the regression loss. So this regression loss is used for many purposes while you do during the regression algorithm. When you're trying to find out the gradient and you want to make sure that the error to be within this limit, this is one of the calculation. Or otherwise you can do for comparison with other algorithms or parametric tweakings. So similarly, during some cases where we have linear separability or non-quadratic kind of separation machine learning algorithms use. Sometimes we might use mean absolute error. So in the description I have given a link which gives certain information about the losses. Okay. Now here also we do the same thing. We take the predicted value and then we subtract it from the original output value. Once we do that, we perform absolute value. So we check those differences. For differences, we take those absolute values, and from that we'll take the mean. So by doing this, we'll get the mean absolute value. This is one way of calculating the error. So there are certain cases for logistic classification. So in logistic classification, what we have happen is in output you will get either zeros or one. So that's the expected output because this is a classification. So in the classification, in order to get a continuous function in machine learning algorithms, we use sigmoid function or we use tan H function. So but this performance is a little bit low. So for in place of them, we use ReLU function or lossy ReLU function. So with that we'll get some values between 0 and 1. So what we have to do is in order to calculate this logistic loss for logistic classification function, so we have a formula, this particular formula. So initially what we do is once we get this predicted values, we start clipping. So clipping is a function which ensures that the given values are between the range of epsilon and 1 minus epsilon here. So once we clip those values, what we do is we'll take the sample space. Sample space is the number of data records. So here number of sample space or number of rows, here we have 2. So what we do is we'll take this prediction and we add little bit bias, and we'll take the logarithm. So we take a little bit bias because in order to ensure that it's not 0, some kind of like that. So we need to take the algorithm and multiply with the targets and sum all those targets and add up the sum with the negative, and this is the cross entropy loss that we get. So this cross entropy loss, again there is a gradient descent function for to have this logistic classification and all those things. So during that time we can compare what is the error. We can set the cross entropy loss particular threshold, or you can compare with multiple machine learning algorithms, or by otherwise you can want to check the error when you have reduced the features. So those scenarios, these kind of losses will be extremely helpful. Thank you for listening this video.